So here we have another telescoping series. Fine. So we have to prove that summation from r equals to 1 to n of r upon r plus 1 into 2 into r plus 1. Okay. Prove that summation from r equals to 1 to n of r upon r plus 1 into r plus 2 into 2 to the power of r minus 1 is 2 power n upon n plus 2 minus 1 upon 2. So, okay, fine. Um, what I initially thought about this question was that I could write it as r into 1 and then 1 can be written as r plus 2 minus r plus 1. uh, but then there's a problem that this r will be left over there and you would not get a proper telescoping series. So instead of writing it like that and eliminating what should I say, eliminating the r from these two, I think we should be eliminating the constant term from these two so that we get something times r on the numerator. Okay, fine. So here's what I thought about it. I can write it as a upon r plus 1 uh, plus a upon r plus 2. I mean, sorry, not a, b, where a and b are just constants, and that will turn out to be something like c into r upon r plus 1 into r plus 2. And instead of writing c, I'll just say it's just 1. Okay, fine. So now our job is to find what these a and b are supposed to be. So we know that a times r plus 2 plus b times r plus 1, that is supposed to be equal to r. Okay, cool. Yeah, so that gives me a plus b into r plus 2a plus b is equals to r. Okay, so that gives me a plus b is equal to 1 and 2a plus b is equal to 0. So that tells me a has to be right, a has to be equal to negative 1 and b has to be equal to 2 in that case. Wait, what? 2? Okay, fine. So yeah, that's fine. So like b has to be 2 and a has to be negative 1. but but if I write 2 over there, okay, let's just see what happens. So there you go, I can write it as um, negative of 1 upon r plus 1 plus 2 upon r plus 2, and let's just see what happens if I write it like that. Okay, so this thing times 2 to the r minus 1, no problem, that is supposed to be equal to negative of 1 upon r plus 1 plus, wait, okay, that's nice, r plus 1 plus 1, and then you have 2 to the r plus 1 minus 1 over there. So it's just the next term, and then this is supposed to be 2 to the r minus 1, and this is the previous term, so it's previous minus next, I mean, sorry, minus previous plus next, so that cancels, right? So yeah, now if we try to sum this, so summation from r equals to 1 to n, what I will get is negative of, first of all I will put r equals to 1 in that, so that will give me 2 upon 2. No, wait, r equals to 1, that gives me 1 actually, so negative half. Then I will put 1 in there, so that will give me 2 to the 2 minus 1, which is okay, fine. So instead of doing all this stuff, let's just write it differently. It's like summation of 2 to the r plus 1 minus 1 upon r plus 1 plus 1 minus 2 to the r minus 1 upon r plus 1, which is the summation from r plus 1 equals to 0 to r plus 1 equals to n plus 1 of 2 to the r plus 1 minus 1 upon r plus 1 plus 1. Right, that looks correct. Okay, and then minus the summation from, guess what, r plus 1, no wait, no, not that, r equals to 1. Wait, is this supposed to be r plus 1 equals to 0? No, it's supposed to be equal to r plus 1 equals to 2. Right, that's more like it. So r plus 1 equals to 2. Fine. So that is some minus the summation from r equals to 1 to n of 2 power r minus 1 upon r plus 1. Now what I will do is that I will substitute this r plus 1 by r instead. So r equals to 2 to r equals to n plus 1, and then you have 2 to the r minus 1. I mean, you can obviously see where this is going with this substitution, minus the summation from r equals to 1 to n. And don't ask me why I did that, because it's a legitimate move, right? Anyone can do that, and it's obviously correct when you have everything which is in terms of r plus 1 and you write it in terms of r. Not bad, I can do that. I can even write in terms of k or any other variable or anything I want, right? So that's supposed to be equal to summation. Okay, so I will write it like this: summation from r equals to 2 to n of 2 to the r minus 1 upon r plus 1. But then for the n plus 1 term, I will write it separately. So 2 to the n plus 1 minus 1 upon n plus 2. Okay, and then minus this summation can be written as summation from r equals to 2 to n of 2 power r minus 1 upon r plus 1. Okay, I'll just put a bracket. But then for the r equals to 1 term, I will write it separately. So that will be 2 to the 1 minus 1 is like, okay, fine, just 1 upon half. Fine, so 1 by 2. So that will turn out to be, you can already see these two terms will get cancelled. I mean, these two sums will get cancelled because they are the same but with opposite sign. So you will just have 2 to the n plus 1 minus 1 upon n plus 2 plus half. Wait, no, not plus half, minus half, right? So that will turn out to be, wait, is that the same thing? Right, so that's the same thing. 2 to the n minus 1 minus 1. Wait a second, is this supposed to be oh sorry, this is supposed to be 2 to the r minus 1, not 2 to the r minus 1. I mean, yeah. So for that n plus 1 term, where did I go? Okay, we will be writing as 2 to the n itself. Okay, fine. So this thing is 2 to the n instead, and you have n plus 2 in the denominator. So yeah, that's our final answer, and that's exactly what we wanted to prove. So there you go. That's how you do this kind of questions. Thanks for watching. I will see you in the next video.